Okay, for this bell work, first thing I notice here is the parentheses, which tells me I'm going to need some distribution. So that's what I will do. I first have three groups of 1x's, which would be 3x's. And then I also have three groups of 5, which would be positive 15. Now, that's just that part of the equation. The rest of it just stays the same, so I just drop it because there was no other distribution. But now I notice that there are some like terms that I can combine, like the 3x's and 3x's. So how many x's will this be? It's just 3 plus 3, which is 6x's. But also I've got 15 plus 1, which should be positive 16. So we show that as plus 16, and then this equals still the negative 32. So that's all the distribution and combining like terms we can do, just like we saw in the last lesson. So now we go into principles of equality. So I'm going to start by zeroing out that plus 16. So I'm going to subtract 16 from both sides. This allows me to drop the 6x, which then equals 16 minus 16, by the way, that's 0. But negative 32 minus 16 would be negative 48. And then one final principle of equality to finish off this problem. To make that coefficient of 1x, I would divide both sides by the coefficient of 6. To make that a 1, 6 divided by 6 is 1. And negative 48 divided by 6 would be negative 8. So that should be my solution, but I'm going to check. So I go back up to the top. I say I'm going to replace this x with 8. Sorry, not 8, but negative 8. All the x's, those two x's, I have now replaced with negative 8. And I can now check for truthfulness. So I got my question mark over the equal sign. Now in the calculator, I just type in 3 parentheses, negative 8 plus 5 close parentheses, plus 3 times negative 8 plus 1 enter. And I get negative 32. That shows me that I do have a true statement when I replace the x, both x's, with negative 8. So I have found the solution. So here's our 3 objectives. I can distribute and combine like terms to simplify equations. Also, I can use principles of equality to create zeros and ones and solve equations. And also, this is fairly new to us. I know when an equation has infinite, one, and none solutions. Now, that last part of the mastery quiz being next time, you don't have to write that down on the classwork, but just know there is a mastery quiz on this stuff next time. So just be prepared for that. Just take another minute, copy these down, then we'll get started. So again, what is the solution? Just like we saw in the bell work, it's a value you can replace the letter with, or variable, that will make the equal sign a true statement. So again, just going back, this means that there are an infinite number of values you could replace the letter with to make it false. We want to know which one, for now, will make it true. Although we saw in the objectives today as well, we'll see some equations that also have infinite solutions, which means you could replace the x with any number and get a true statement, but we'll see. So principles of equality, we need to review this as many times as we can because it's not going to go away. So whatever you do to one side of the equation, you got to do the other side, but we're doing these with purpose, right? So if we use addition or subtraction, this means we're trying to make zeros. And just like we saw last time, we're now trying to make some of the x terms zeros if there's x's on both sides of the equal sign. There wasn't on the bell work, but we did see some in the last lesson that did. So sometimes we have to zero out x terms because they're on the wrong side of the equal sign. Or we can say that it's to isolate the variables, get them on their own side of the equal sign. So once that's done, then we can force values to be ones. And usually it's just the coefficient. And I think we've seen this enough where we hopefully know now that if we're going to make one, we usually use the division principle of equality. If for some reason we see the x in the fraction, sometimes we do use multiplication principle of equality as well, but it's less used than the division principle of equality. But again, all this, we're doing this with purpose. Whatever you do to one side, you got to do the other side of the equal sign, but we are doing it with purpose. So general strategy for solving equations. First, you're going to distribute. If we're looking to distribute, then we'll have to see some kind of parentheses in the problem, in the equation. There we go. Okay, so we'll distribute. Again, if we see parentheses, we know there should be some kind of there has to be some kind of distribution, because distribution is multiplication. And then we may see some need to combine like terms, which we did on the bell work. Of course, you cannot combine like terms across the equal sign unless you're going to use principles of equality. So that's why we separate 2 and 3 there. Then if you need to use principles of equality, you're gonna force values become zeros first. This is going to isolate the variable. But again, we can zero some of those out if we have x's on both sides of the equal sign, because we don't want them on both sides. After that, we'll use division or multiplication, usually division, to force the coefficient to be a 1. But again, that value must be a positive value. But again, just going back to the last lesson, if you saw something like this, negative x equals 8, this is not complete. You need to make sure that the coefficient is a positive 1. Right now, it is a negative 1 coefficient. We always need the coefficient to be a positive 1, not a negative. So just keep that in mind. You'd have to divide both sides by negative 1 on this particular problem. So we saw a question like this last time. No problem. We can still work with it. So I'm going to go to principles of equality, and the reason why I'm doing that is because I do not see any distribution that's possible. Also, the two terms on both sides of the equal sign, like the 14x and the negative 18, I can't combine those because these are not like terms. Same with the 6x and the negative 10. These are not like terms that I can combine, so I can't, and I won't. But what I will do is I will at least say I just want my x's on the left side of the equal sign, and then I want my constants or numbers on the right side of the equal sign. So I'm going to go through each term, and I'm going to determine if it's on the correct side. If it's not, I have to zero it out. So the 14x, that is an x term. It's on the x side of the line, so I'm not going to do anything with it. The negative 18 is not an x term, so I need to zero that out by adding 18 to both sides. Okay, so again, with purpose, we're doing this. That zeroes out that negative 18. I can now drop my 14x, which equals, I'll drop the 6x as well because we didn't do anything with it. And then I have negative 10 plus 18, which is positive 8. Now, a side note to what I just did, I did not put the plus 18 below the 6x because it's not a like term that I can even combine that 6x with. I can only combine it with the other constant, which is negative 10. So do not do plus 18 with that 6x's because they're not like terms. However, the next principle of equality that I'm going to use, I'll combine the x's. So here's what I mean. The 14x, it's still on the x side of the line. The 6x, though, is on the number side of the line. That shouldn't be there, which means that I need to zero it out by subtracting 6x. If I do it to one side, I will do it to the other side as well. So 14x's minus 6x's would be 8x's. 6x's minus 6x's, that zeroes out as planned. And then I'll drop that's positive 8. So one final principle of equality will do this in order to force the coefficient of x to become 1. We know we need either the division or multiplication principles of equality. That's 8 times x, so I will divide the 8 by itself, 8. But if I do it to one side, I'll do it to the other side. So 8 divided by 8 is 1, and also 8 divided by 8 is 1. So this means that x should be 1 if I go up here to the top, and I say I'm going to replace these x's with 1s. Let's see what happens. So I'll replace that x with 1 and this one with 1, and then I will check for truthfulness. On the left side, I've got 14 times 1 minus 18. I get negative 4 on the left side of the equal sign. On the right side, I have 6 times 1 minus 10, which is also negative 4. Negative 4 does equal negative 4. That is a true statement. And then I know for sure that I do have the solution to the equation. So this is just more of the same. Just this one should be kind of like review. But we'll expand on these. Again, it's not like it becomes harder. It's just more work. This one, just like we saw last time, there is a need to distribute a fraction. But distributing the fraction hopefully is not, it's not a concern, because I'm just going to use the calculator to do it. Now, distribution here is multiplication, so I'm going to take my negative 8/3 and multiply it by negative 8x's. But since I'm putting that in the calculator, I'm going to put the negative 8/3 in parentheses like this. And then I'll multiply. So, and you can't put the x in the calculator because it may think something else. So this is just 64/3 x's. And then also I have a negative 8/3. Again, since I'm doing this on the calculator, I'll put it in parentheses. That's times negative 6. So that would be positive 16. And then this should just equal the other 20 there on the right. So from here, now that we've done the distribution, I do not see any like terms that I can combine, so I won't. But I will zero out that plus 16. Okay, now you notice I'm not choosing a side for the x's. That's because I have all the x's on one side already. I don't need to say I need to see if there's any x's on the right side. There's none there. So I'm going to zero out that plus 16 with a minus 16. I just need to do it to both sides. So that's going to zero that out. So that allows me to drop my 64/3 x, which now equals 20 minus 16, which is just 4. Last thing I'm going to do here is I need to make the coefficient of x a 1, which I can do. Even though that's a fraction, it's no problem. I can just divide that coefficient, 64/3, by itself. But if I do it to one side, I need to do it to the other side as well. Now remember, in these calculators, when you're putting the fraction in, you should use parentheses, and also the fraction button is just the divide button. So I push 4, divide, parentheses, 64, divide, 3, close parentheses, enter, and it gives me this, I think it's not such an ugly decimal, but it's not great, 0.1875, which, that's fine. I do want to see what the fraction is going to look like, though, so remember to get the fraction, you're just going to push math, enter, enter. So math, enter, enter. And it shows me, I like that better, 3/16. Okay, so either one of these should work. But let's go up to the top. There's only one x to replace. I'm going to use the 3/16 just because I think fraction's prettier, but the decimal would work as well. So let's see, we've got negative 8. Oh, I got to put that in parentheses because it's a fraction. Negative 8 over 3, close parentheses. New set of parentheses, negative 8 times parentheses, 3 over 16, close parentheses, minus 6, close parentheses, enter, and I do get 20. So when I check this, I got 20 on the left side, which makes the equation true if I replaced the x with 3/16. That also means that 0.1875 would work. Either one is good. Both are the solution. On the assignment, it should tell you if you need the decimal or fraction. If it doesn't say, then it usually accepts both. Okay, so here we see this one. Yeah, it's a little bit bigger, right? But just because it's bigger doesn't mean that it's more difficult. So right off the bat here, we'll start by distributing. I'm going to distribute this. Remember, it's a negative 6, not just a 6 right here. So that's negative 6 times 9x's, which would be negative 54x's. Then I also have negative 6 times 4, which is negative 24. Okay, so that's the first distribution. I also see this other set of parentheses. So I need to distribute the 18 into the second set of parentheses. I would show this as 18 times negative 1x, because I like to see that phantom 1. That would give us negative 18x's. But also we have 18 times negative 1, which is negative 18. Okay, so the rest of it just drops. We do have the 14x, the equal sign, and then the plus 2x, positive 2x. Okay, so both sides had some distribution, which we did. That wasn't too bad. But now we see on both sides there are also like terms to combine. They just happen to be x terms, both of them. So right here for my x terms, I've got to take 14 and subtract 54. That's going to result in negative 40x's. Okay, now for the left side, there's nothing to do with the negative 24, so it just drops. Right, we didn't combine it with any other constants there. On the right side, though, I have negative 18x's plus the 2x's, and negative 18 plus 2 is negative 16 x's. And then, yep, the negative 18, it just drops. Okay, so this is my new equation after distribution and combining like terms. That's as simplified as I can make it right now. But now that we have completed both of those, we're ready to use principles of equality. So once again, I'm going to show that I would like for the x's to be on the left, and then I'll put all of the numbers or constants on the right. So just like hopefully we're getting a little used to, I'm going to scan this. I've got the negative 40x. It's an x term, so that's okay. It's on the side that I want it on. The negative 24, though, it's not an x term, so I need to zero that out by adding 24. But yes, if I do it to one side, I must do it to the other side as well. So that will zero that out. I can drop the negative 40x, which now equals, I'll drop the negative 16x as well. And negative 18 plus 24 ends up being positive 6. So again, it's just simplified. It's a much smaller equation now, and we can make it even smaller because in scanning this, we see, and so I'm going to use a principle of equality here. I got this negative 16x. It's on the number side of things. That's no good. I need it to be on the x side of things. So I'm gonna have to get rid of it, which means I'm gonna have to zero it out. So I'm gonna add 16x to both sides. Okay, so on the left, I've got negative 40x's plus 16x's, which ends up being negative 24x's. The negative 16x's plus 16x's, that zeroes out, and then the 6, which is positive, it just drops. So I think I have enough space here, but one final principle of equality will do it in order to force the coefficient of x to become a 1, which is what we do want. So that negative 24, I'm going to divide it by itself, by negative 24. That will become a 1, but if I do it to one side, I need to do it the other side as well. Okay, so I got 6 divided by negative 24, and my calculator shows negative 0.25, which if you push math to enter, it'll give you the fraction as negative 1/4. Now, negative 0.25 isn't too bad. So right now when I go and check, there's a few x's I've got to replace, right? So I've got this first one, negative 0.25. This one as well, negative 0.25. And that would be the left side, but on the right side, we also have this one, negative 0.25. And then this one also, negative 0.25. Now, the thing that you'll have to be careful with is in checking right here. This is a negative, and then you got the parentheses negative. That's okay. The calculator knows exactly how to do that. So I got negative 0.25 as my x's. Let's go and type this in. I got 14 times negative 0.25 minus 6 parentheses, 9 times negative 0.25 plus 4, close parentheses. I push enter, and on the left side, I got negative 14. Okay, now the right side, right? So I got 18 parentheses, negative, and then I type in the parentheses, negative 0.25, minus 1, close parentheses, plus 2 times negative 0.25. Enter, and I also get negative 14 on the right side. So just right here when we just checked, we found that it was true. So now I know for sure, and either one of these would work as the solution to this equation. Well, that last one was big. This one's much smaller. Hopefully that means it's just going to take less time. Remember, the size hopefully is not going to change whether it's difficult or not. It's just more work like that last one was. But hopefully it's no problem. So right off the bat here, I see parentheses, right? So I'm expecting some distribution. First off, I'd have negative 8 groups of 2x's, which would be negative 16x's. Then I have negative 8 groups of negative 2, which is positive 16. All right, so that is going to equal negative 16x plus 16. Now that, I just said that out loud, and some of you may have thought some weird things in your head because something strange is going on here. We'll find out what that is. Okay, but first, I see there's no more distribution. There's no more combining like terms. In fact, there wasn't any. So I'm going to go straight into principles of equality. Although we'll see that we could be done at this point, but I'm going to continue because this is the first time we may have seen this. So I got my x's on the left, numbers on the right, the constants on the right. Scanning this, I got this negative 16x, that's okay. But the plus 16, that's not okay. So I've got to zero that out with minus 16. But if I do it to one side, I do need to do it to the other side. So this is going to drop my negative 16x, which equals, now because we just zeroed out the plus 16 there, this allows me to drop this negative 16x. And then I have 16 minus 16. While that is 0, I need to show that it's 0 because I need some constant on the right side, right? That's why I put this number symbol here. So if I have a number, even if it's 0, that's okay. I just need to show it. Another principle of equality, and we'll see what's happening here for sure. But remember, we've got this negative 16x. It's on the number side of things. Garbage. I don't want it there. I need to get rid of it. And by get rid of it, I need to zero it out. I'll add 16x. But if I do it to one side, I need to do it the other side. So from here, let's see what we get. On the left side, negative 16x's plus 16x's. I need to see how many x's I get, and that's 0 x's. On the right side, negative 16x plus 16x. I'm zeroing that out, so I don't actually want to see it down here because it's an x term. But I have the purple 0 here that I can drop as well. At this point, we're done. But some students mistakenly say that x is 0. Now remember, we needed the coefficient of x to be a 1, a positive 1. This is not a 1, that's a 0. So what does this mean? So we look at this equation that we have, and we need to ask ourselves a question. What can I multiply 0 by to get 0? Because that's really what this equal sign is asking. What value can you replace the x with to make this true? As it turns out, you can multiply 0 by anything. In fact, I'm going to emphasize that. Anything, and get 0 back. Okay, so in other words, this statement, this equation is always going to be true. Now that may seem weird. What does this really mean? Well, it means that up here at the top, if you replace x with any value, any decimal, any fraction, any negative value, you're going to get a true statement, always true. And that's because this final statement, once we simplify this down here, this will always be true. Now, like I said, we could have been finished up here, and that's because the two expressions, negative 16x plus 16x, it was the same on both sides. This is negative 16x plus 16. It's the same on both sides. Once you see this, you could have stopped right there and then just come to that conclusion that we want, which is that at this point, you could have said there are infinite solutions. So this is related to the objective. If you see something like this, you now know how to determine if there's infinite solutions. I should put an S there. So that's what I'm trying to say here, is that the actual answer here is just to say there are infinite solutions. In other words, any value that you replace x with would be true. It's possible as well, they may say something like all real numbers. And I don't really know which one that they will use. But they may say either one. Just know they mean the same thing. So infinite solutions, just like we saw, it means the equation will be true for any value you replace x with. It's always true. And again, we see that when one side of the equation matches the other side. And that's kind of earlier in the problem. That may take some time to get used to. It's also going to happen if we see 0x equals 0 after solving the equation as much as we can. Once you see 0x equals 0, you just know that there are going to be infinite solutions. If there were no solutions, this means that you couldn't replace x with anything and get a true statement. It will always be false. Okay, so this usually shows one number equals a different number. Or what you may see usually is something like 0x equals anything but 0, right? And again, the reason why this is going to be no solutions is because what can you multiply by 0 and get not 0? You can't do it with any number, okay? So mathematically, we say that's impossible for now. So we just say, in that case, that there are no solutions. So as of right now, from the equations we've solved, we can't have one solution. It's possible to have infinite solutions or no solutions, but do be aware in mathematics we can force there to be 2 solutions or 3 or 4 and so forth. But for now we're just focused on these 3, 1, infinite, and none solutions. So let's see what happens here. Okay, so we got some distribution definitely because I see these parentheses. Okay, we got 2 sets of parentheses. Let's do one at a time. Here I'm going to be distributing in -1. So that'd be -1 groups of -6x's. That's positive 6x's. But also I got -1 groups of 7, which would be -7. And this should equal, let's distribute this -2. So that's -2 groups of -3x's, which is positive 6x's. And then we have -2 groups of 4, which is -8. Now, this is kind of matching right here, but it's just the x's that are matching. We got -7 here, we got -8 there. So you could make the conclusion at this point, but again, we just don't have the experience to do that yet. So let's keep going. So there's no more distribution, no more combined like terms. I'm now using principles of equality. I'm going to keep my x's on the left, numbers on the right. And if I haven't said this yet, you can switch these. I just always like to have the x's on the left. So at this point, I see this -7 on the x side of the line. No good. I don't want it there. So I will 0 it out, and that will allow me to get rid of it. So add 7. I just need to do it on both sides. So drop my 6x. -7 plus 7 is 0 as planned. And then this will equal, I can drop this 6x as well. -8 plus 7 is -1. Now I've got this 6x on the number side of things, and that's no good either. So I will have to 0 out that 6x in the red on the right. So that's going to be subtract 6x from both sides. Now again, just like I said in that last problem we did, is I got my x's on the left, so I need to show how many x's this is going to result in, and 6 minus 6 is 0. I need to show that, okay? On the right side though, since that's the number side of things, I don't actually want to show this one, so that's why I'm zeroing it out right there. Now I can drop my -1, and now I can see a kind of a new problem right here, which we talked about in that last slide. But again, it becomes an equation. What value can you multiply 0 by to get a -1? Well, there is no value you can do that with. So what I'm trying to say here is that this one has no solutions. Okay, and we'll just box that in. Again, this is really telling us no matter what value you replace x with, the equation is always false. Once you get a little bit more experience, you probably could have told up here, because you have the x's that match, but then the numbers don't. And then you could say, well, even at this point, right, how can 6x plus nothing equals 6x minus something? It can never happen. So whether you notice here that the x's match and the constants don't, or here, doesn't really matter, or even here at the end, as long as you understand there's no solutions. So for this one, we got some distribution here. Don't forget that this 6.8 right here, whatever it is, it's negative. Okay, so when we distribute, which is multiplication, we actually need to take negative 6.8 here first and multiply it by negative 7.1 x's. So I just take my calculator, negative 6.8 times negative 7.1, enter, and I get 48.28 x's. And then also negative 6.8 times 1, just negative 6.8, that's not too bad. But then we got the 14 distributed into this set of parentheses here. So that'd be 14 groups of 4 x's, which is 56 x's. And then 14 groups of positive 3, which would be positive 42. So the rest of this just drops. So we got the 8x, and then that 48.28 x's is positive, so I got a plus sign there. Minus 6.8 equals 56x plus 42, and then minus 4. So from here, we have an equation, but we do have some like terms that we can combine. I see I've got the x terms right here, which is 8x's plus 48.28 x's. So how many x's is that? It's 56.28 x's. And then on the right side, we got the 42 minus 4, which would be, looks like positive 38. So my new equation, 56.28x minus 6.8 equals the 56x plus the 38. Kind of offset there, but that's okay. So now, another principle of equality, because we have done all the distribution and combining like terms that we can. So right here, I'm saying that I would like the x's to be on the left and the numbers on the right. All I have to do at this point is just scan and see if values are where they should. Like the 56.28x, it's on the x side of things, and it's an x term, that's okay. But the negative 6.8, that's no good. So I'm gonna have to take it away by zeroing it out, by adding 6.8, just add it to itself. But if I do it to one side, I do need to do the other side as well. That will zero that out, and then I can drop my 56.28 x's, which equals, we can drop the 56x as well. And then 38 plus 6.8 would be positive 44.8. And now, looking at this, I've got this 56 x's in red on the number side of things, but that should only be constants on the right side, so I need to zero that out as well. So that's what I will do. I will zero it out by subtracting 56 x's from both sides. And on the left side, 56.28 x's minus 56, that'd be 0.28 x's. And then this would equal, we zeroed out these x's, but we can drop the 44.8. And then last of all we got is one final principle of equality to make the coefficient of x a 1. So to do that, we use the division principle of equality. Here, I'm going to divide the 0.28 by itself, but if I do it to one side, I'll have to do it to the other side as well. So in the calculator, 44.8 divided by 0.28, enter, and I get exactly 160. So if I come back up to the top, I say I'm going to take the x's, all the x's, and replace them with 160. There's that one, here's this one, that's all the ones on the left. And on the right side, we only have this one. But I'm going to take this and I am going to check for truthfulness. So in my calculator, I've got 8 times 160 minus 6.8 parentheses, negative 7.1 times 160 plus 1 close parentheses. And on the left side, I get this, well, it's kind of a big number, but it's doable, 8,998. On the right side, we should get the same thing. Let's find out. 14 parentheses, 4 times 160 plus 3 close parentheses minus 4, enter. And I get the same answer, 8,998. So that is true. Since we got a true statement by replacing the x with 160, I now know that it is the solution. same objective as the beginning of the lesson. I can distribute and combine like terms to simplify equations. And also I can use principles of equality to create zeros and ones and solve equations. But also now that we've gone through the lesson, we should know, hopefully, when an equation has infinite one and none solutions. That last part of the mastery quiz being next time. Again, you don't have to write that down. But do understand there is a mastery quiz next time. So again, we'll have the bell work, then we will have a quick review, and then we will have the mastery quiz.